The last video, when we were talking about the method one, okay, I said that the question normally is followed by two plane equations. Okay, so let's write down equations for planes. Yeah, so phi one is given by let's say it is given by I don't know, like x minus two y plus six z equals to 7, and let's say pi 2 is given by 3x plus y minus 2z is equals to 9. Okay, so when they give you the parametric equation, I mean the Cartesian equations of the plane, I said they will also provide you a point on the both planes, okay, or a point on the line, which is the intersection of these two planes, because we know when two planes are intersecting, I'm just drawing a rough diagram. Okay, when two planes are intersecting, they intersect at a given line. Okay, and we are doing a question like this, they normally give you a point on the line. Okay, so I was going through some resources. Okay, and I noticed that they don't actually have to give you a point on the given line or the in the two planes. Okay, let's say this is pi one, and let's say this is pi two. And first of all, let's check whether these two planes are parallel to each other. How can we check that? First of all, we have to find the n1. Okay, so n1 will be equal to, let's say, phi 1 is perpendicular to n1. Okay, so which means n1 goes like this. Okay, so this is the 90 degrees, and n1 can be written down as 1 comma minus 2 comma 6, and similarly we can give n2, which is the normal vector to phi 2. So n2 will look like this. So let me draw that too. So this is 90 degrees, so this will be n2. Okay, so we can say that as 3 1 comma minus 2. Okay, so we can clearly see that n1 and n2 are not parallel. Why? The ratio is 1 over 3 and minus 2 over 1 and 6 over 2. They are not equal to each other, which means we can't actually give the vector n1 as a multiple of n2. So we can say n1 is not parallel to n2, which means pi 1 is not parallel to pi 2. So there is an intersection. Okay, and let's name the line L, which is the intersection of these two planes. So when I was teaching this yesterday, okay, I said that they will normally give you a point on the line. Okay, they will give you a point on the line. But actually, they don't have to give you a point on the line. Okay, you can actually find out a point on the line. I mean, on the plane, pi 1 and pi 2. Okay, so how can you do that? You can substitute a value. Okay, you can let x equals to 0 or y equals to 0 or z equals to 0, and reduce the equation of the system of equation into two simultaneous equations, into two variables. Then you will find the values for the other two variables, and you can find the common point. They don't have to give you a point on the two planes. Okay, so let me do this question so that you can understand. So we know pi 1 is given as x minus 2y plus 60. Okay, so what I'm going to do is, let v is equals to 0 in pi 1 and pi 2. Okay, in pi 1 and pi 2. Okay, so which means I can come up with two equations, which goes x minus 2y is equals to 7, which is the first equation. Then I will have 3x plus y is equals to 9, which is the second equation. Okay, so we can simply solve this by, here we have minus 2 and here we have 2. So if I multiply two second equation by 2 and add it with the first equation, I will get 7x plus 0y is equals to 2 times 9 is equals to 18. Okay, 18 plus 7 is equals to 25. Okay, so this is equals to 25. So we can say x is equals to 25 over 7. Okay, so I can substitute this. Okay, I can substitute this in the first equation. So if I sub x equals to 25 over 7 in the first equation, okay, in the first equation, I will get 25 over 7 minus 2y is equals to 7, which means 2y will be equals to 25 over 7 minus 7. Okay, so that is minus 49, and minus 49 means minus 24 over 7. Since 2y is equals to minus 24 over 7, y will be equals to minus 12 over 7. Okay, so here what we have found out is the point. Okay, let's say point P, which is given as 25 over 7, okay, and minus 12 over 7, comma 0, okay, actually lies on the plane pi 1 and pi 2. Okay, if you want to, you can actually verify this. Okay, you can actually verify this. How can you verify this? I mean, I won't encourage you to do that because you don't have to. Okay, but if you have any doubts, you can actually verify this. So let's substitute x, y, and z values of p on pi 1. And if it is equals to 7, well, then it actually lies on pi 1. So let's say for pi 1, okay, we are verifying for pi 1, okay, so we have the left hand side, LHS can be given as 25 over 7 minus 2y, so it will be plus 24 over 7, okay, plus 24 over 7 plus 0, that is equals to 49 over 7, which is equals to 7, okay, so this is equals to right hand side, which means point P lies on pi 1. Similarly, we can go to the phi 2, the plane phi 2. So here we can say LHS is given by 3x plus y plus minus 2z is there. So 3x can be given as 75 over 7 and y is equals to minus 12 over 7. So it will be minus 12 over 7 plus 0 because 2z is equals to 0. This is equals to 63 over 7, which is equals to 9, which is equals to RHS. Okay. So by verifying this, we have made sure that the point P actually lies on the both planes. Point P actually lies on both planes. Okay. So now, since we know a point on the line, okay, now we know a point on the line, which is given as 25 over 7, comma minus 12 over 7, comma 0. Okay. So this is what we have found out. Now you can do the normal drill that we have learned in the last video, where the direction vector of the line L. Okay. So let me write that down. Let's remove all this because we have completed all this. So we'll remove this. So say let L is equals to L is given by R equals to A plus lambda B. Okay, A plus lambda B. A will be equals to the point P. Okay, now we have to find B. So B can be given as the cross product of N1 and N2. Okay, so the cross product or the vector product. Okay, so we'll write down the IJK components and we have 1, minus 2, 6 and 3, 1 and minus 2. So this will be equals to I into minus 2 into minus 2, 4, minus 1 into 6, 6, minus j into 1 into minus 2 minus 2 minus 3 into 6 18 plus k into 1 into 1 1 minus minus 6, so it will be plus 6. Okay, so this can be given as minus 2i, okay, plus 20j, okay, plus 7k. Okay, so this is the vector B. Okay, so vector B can be given as minus 2 comma 20 comma 7. Okay, so the line can be written down as, okay, R equals to A is given by 25 over 7, 25 over 7 comma minus 12 over 7 comma 0 plus lambda into minus 2 comma 20 comma 7. I just wanted to clarify that you can find a common point on two planes, and I should have explained that better. I hope this clears things up. So they might give you sometimes. Okay, if it's a small question like for 2 marks or 3 marks, they might well not that much. Well, let's say 1 mark questions. Yeah, if it's a 1 mark question or a short structured question, they might give you the point on the line. If they don't give you the point on the line, you should be able to find the point on the line. Okay, so keep that in mind. This is not the second method. This is the first method. We are still in the first method. We are not yet finished the second method. In the second method, we will be using a different idea, exactly different idea, entirely different idea, in which we will talk about the parametric equation. That is actually kind of useful. Okay, that is kind of useful. But if you are solid with the vector product, okay, which I highly appreciate, if you are solid with vector product and the simultaneous equation, you should try this method because this directly gives you the vector equation. Okay, so that's it for this video. This is just a extended version of the last video. Okay, that's all. Because I wanted to clarify this because we can find the point on the two planes if you wanted to. So yeah, you don't have to verify this. Okay, you don't have to verify if the point you have found is correct, because when you're doing the simultaneous equations, you will normally come up with the correct answer. Okay, so you don't have to worry about that. And in this case, I have let z is equals to 0 to find the value. You can even give x as 0 or y as 0. Okay, that depends on your preference. Okay, why did I give z as 0? Because here I had 6z. Okay, so if it comes to a simultaneous equation, that will be a little bit of a headache. So that's why I gave z as 0. But if the equation was something like this, okay, let's look at another example question. Okay, so let's say pi 1 is given as 7x plus 2y minus z is equals to 7, and pi 2 is given as 9x plus y plus z is equals to 3. Here I will give x as 0. Okay, I will mark x as 0. Definitely they are not parallel to each other. Okay, so that's not an issue here. I would give x as 0, okay, to find the other values, because this is pretty easy, right? Because if x is equals to 0, I can definitely say that y is equals to 10 over 3. Okay, y is equals to 10 over 3. Since y is equals to 10 over 3, z will be equals to minus 1 over 3. Okay, z will be equals to minus 1 over 3. Okay, so well, you can do it by yourself. Okay, so yeah, let's keep this as an homework. Okay, I will share the answers with you in a post. Okay, don't forget to look at there, and yeah, keep learning, because we are approaching the three planes, which is the last section of the plane. So yeah, stay tuned.
Thanks for watching the 37th video in our vector series. If you found this clarification on finding the common point on two planes helpful, don't forget to like, share, and subscribe for more tutorials. Hit the bell icon to stay updated with our latest videos. Check out the full playlist to master vectors and follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious.